Okay, so right now you should have this worksheet in front of you. You're gonna pause the video and then you are going to do this warm up. And when you're done, you can resume. Okay, so you should have gotten these answers for each one. Okay, these are all independent of each other, so they're not based on the one before it. So today what we're gonna be doing is we're gonna be talking about proving lines parallel. So we are going to be talking about all of the angle relationships that you have in your notebook. Alternate interior, corresponding, all of those, but we're going to flip it. So we're going to be doing the converse of all of those theorems that we've talked about. And by this point, you should know what a converse is. So what we've been doing in the past is we've been saying, okay, if these two lines are parallel to each other, so if M is parallel to N, then we can say something about these angles, right? Now we're doing the opposite. Now we're saying, if we know something about these angles and their relationship, then we can conclude that the lines must be parallel. So the first converse that we're talking about is the alternate exterior angle theorem converse. So what it's saying is if the measure of angle 1 is congruent to the measure of angle 2, then these lines must be parallel to each other. So we're deducing that these two lines, H and D, must be parallel. So you should be able to see at this point that we are doing the opposite or the converse. So we're looking at the angle pairs to prove that the lines are parallel. Where up top, you knew the lines were parallel, right? And you were trying to find something out about our angles. So the next one is the alternate interior angle theorem converse. So if angle 1 is congruent to angle 2, then F must be parallel to E. Because these two angles are congruent, these lines have to be parallel. Consecutive interior angle theorem converse, which is the same as same side, right? It just has two names. So if 1 and 2, if these two angles are supplementary, right, they add to 180, then M must be parallel to L. And let's flip it to the back. Our last one is a corresponding angle postulate converse. And just like the others, it says if 1 is congruent to 2, then M must be parallel to L. And you should kind of be able to see that this has to be true. But if you remember when we talked about parallel lines and we talked about this theorem that said if these two lines are perpendicular to the same line, right, then they must also be parallel to each other. And you guys gave me a lot of good answers to come up with why that's true. Now, we said that in non-mathy words, that if these two are perpendicular to the same line, then they must be traveling at the same degree, if you want to call it. So same deal when we look at all of these converse theorems. If these two corresponding angles are the same degree, then these two lines must be parallel. They are traveling at the same exact degree. Okay, so that's where this all comes from. It's just the converse of what we've been talking about before. So before we were saying if these lines are parallel, then these angles are congruent. All we're doing is switching it. So what you're going to do now is you are going to complete these practice problems and you are going to turn it in. And then once you are done with that, you're going to go back onto Schoology and you're going to look on the instructions from there.